Morning guys, Mike Sheck, May 25th, 2022. I'm going to show you the industrial field. I'm in a tank farm where everything gets shipped and stored, and we take it from there and send it into the plant itself to be processed. We have a chemical here that in a tank 50109. If you go over here, we got a lock valve here, which is an output with two inputs. The inputs are the open and close. The outputs are the solenoid itself. You go here, we got a flow meter, which is a 4 to 20, right? Input back to the DCS. Tells you what the flow is they're getting out of this tank, right? And you can see that they got a pump to regulate it. And normally that's on a VFD, which we'll talk in the shop and a little more familiar about it. Then we go over to here, we got the same process. We got a block valve, and then we got we have a level transmitter on the bottom of this tank. Tells you what the level is. You can see it right there. Again, the level transmitter is a analog input back to the DCS. And then there's a block valve there. And again, if you look, I'm on a tank here that is measuring a level. I'm just showing you it's probably about 24 feet high. All right. Same way here. We got a block valve. We got a valve right here, a hand valve. Then we go over here. We got a block and bleed, double block and bleed. What that does is so we can work on this and pull this block valve out. We can open and close these valves accordingly to drain, so we can pull the valve or pull the pump. So we're able to drain it, and that's what a block and bleed looks like. Again, we got a flow meter here, which tells you what the flow is, all right, coming out of this pump. Again, we'll talk about that. And then we go out to the field boxes. We have an I box, which is here. And we got an E box. Again, from this here, it goes back to the DCS, which I'll talk about in a couple minutes when we get back up there, what the DCS is. So they take a multi-conductor wire. This is a 2-wire multi-conductor. And they landed in the terminal box. If you look, I see LT. So I would stand for instrument, right? In this plant. So you got TT there. I got an LT, level transmitter, flow transmitter. Depending on what tank it's on, you can see how it's labeled. Same way over here. It's all detailed. Very important for detail. And that's the instrument panel or box. We go from there, we got the electrical box. Right? The electrical box is all the inputs and output, discretes, solenoids and stuff like that. And control wiring for. And you can see we got some fuses here. And if you look specifically, you have ZSO, which is a close for 5319. And you got the one above it, which is a closed signal. And then you got the solenoid. That's what I'm showing you right here. All right, UV 5039 is the solenoid. Then you got the open, and then you got the closed, if you see it. Okay, and then this is the electric. You don't mix electric and instrument together because of the interference. Okay, I'm trying to do the best I can here to make this work. So we'll see. And again, I'm in a tank farm right here, showing you the process to get you to see what I have in the plant. Again, this is a sump pump, measuring the flow, what's in the sump pump. We have a temperature transmitters. We got another flow transmitter. Like I said, we got a level transmitter over there, right? If you look at, this is the silo here, that's the one on. If you look, remember I said repeatability, redundance, I'm sorry. There's a flow instrument up there for a high level. Well, if this gets high, they'll shut the valves and everything so the process won't overflow the system. All right, and then you come down here, you can see that what we have are block valves here, which are inputs and outputs. The inputs are the limit switches in the heads, and the solenoids are the outputs from the DCS. And again, I'm just walking, showing you the different instruments here. I got a flow meter here, different type of flow meter. We got a solenoid here to open and close something. We got a flow transmitter here, which is all the way on the other side, which goes right here. All right, just pointing out things that you can see. I got a flow meter here, again, and a block valve. Again, these motors are working off of DC drive, which is a variable speed drive. And then I'm going to walk, so it is what it is. This is a process that we have down here. If you look down here, we got a control valve. Right, this is a control valve here. This is a block valve. This is an analog output. This is a discrete output. Input on the discrete input, open and close. There's the solenoid. Right? Block valve opens. Control valve controls the process. Right? There's another type of control valve. That's a big one we have in the plant. For bigger, there's another flow meter measuring the flow on that, so that control the valve or that control valve, whatever flow they're looking for, that control valve opens and closes accordingly. All right. So I'm showing you as much as I can. Then we go over here. I got another process. I got control valves right here. This is the control valve, an I to P. We talked about it in the shop. 4 to 20 turns into 3 to 15. It opens and closes that. Then we got a flow meter. Then we got block valves. This is acid here. So we have all kind of blocks and bleeds, so we can pull this stuff and work on it. If you look, this is for lockout and tag out, so we can work on it and pull the instrument. Again, if you go over here, we got a block valve. We got a flow meter. Flow meter. They're both two different types of flow meters. Okay, and this is all acid. And again, we got another process here, which is controlling the acid. We got a flow meter. We got a control valve. We got a block valve. Again, so you can see what we have here. There's another different type of control valve, right? Here's the I to P again over here, but it's a different type of control valve. This is a flow meter. This is a block valve, right? Inputs and outputs that we all talk about in class. These are pH meters. Some we don't talk about in class, but again, these are the pH 4 to 20. And then we got a different type of level control here. We got a level control, right? Full capsule like we have in the class for a high and low DP, differential pressure. And again, when I was in the tank farm, I had a terminal box there for the tank farm. Now I'm over by the acid pumping stations, and now I have an I to E panel here, just like I had over there in the tank farm. So I'm just walking because I can't turn the phone off, and just showing you. Again, here's a pressure transmitter, and there's a temperature transmitter, right? This is the way it looks like in the real world. These are the instruments, right? And if I trace them out, it probably goes over to a terminal block, which is here. And these are probably where right here are the hockey pucks that we have in class. And they're analog inputs back to the DCS, okay? And if you look, this is a 3-wire RTD, and instead of coming from here, it goes from here, goes up, goes around, comes down, and the thermocouple's right here. So the thermocouple wire, the RT wire, the RT wire goes up into the pipe. It's only about maybe 20 feet at the most, 25 at the most away. But these pressure transmitters here and here have a 4 to 20, and that comes right from the terminal right to there. All right. Again, that's the tank farm that I was at. That's the bike I ride all the time. This is the plant that I'm working on. Like I said, when we go there, this is the distribution. The high voltage coming in, the substations, that goes from here and feeds the rest. I'm walking through the rest of the plant. This here is another process. Right here we got pumps, we got different tanks, different acids, different chemicals, different products in it. Again, you can see acid luminide, you got sodium, right? And again, I'll talk about it when I get up here. I'm walking through the plant, so again, this is another control process, a complete loop. You got the flow meter, you got the lock valve, you got the control valve. The flow meter tells the control valve what to do, open and close, and tell them what you want to run. Same thing if you look at this flow meter, it's showing 0. Look at the output, it's closed. So if you look right here, we got 0.9. That it's a little above, almost 25% to get to 0.8 or 0.9. That's one type of flow meter. This is another type of flow meter. That's what we have in the shop. Again, this is a high level for this tank. So I'm on top of the tanks right now. You can see a high level there. Bottom of the tank, there's a level transmitter on the down level. Okay? Look up at the ceiling there, I got a control valve, the lock valve, open and close, and tell me what process to put in, and open and closing that valve. This is another type of control valve. I've got a block valve in front of it, and I've got a flow transmitter. Redundant, that's what it is. Again, I got a control valve here, right? Showing whatever I'm taking out of this tank to put up on the process up top. This is the lock valve, again, open and close. Go down here. I got a control valve. Control the process. Goes from there. You can see what we have. Right now, this process is running at 14.52. You can see the valve open 25%. This process is not running. And you can see that the process through the valve is 100% closed. So, there's different ways to go. Different control valves, different lock valves, either hand valve. So if we have to work on this, we're going to lock and bleed. Right? We got a hand valve there, we got the lock valve here, bleed here, and there's a bleed around the corner there. from this point, we're going to go to the DCS on the MCC. So from the MCC, the 480 comes from the MCC, right? And this is the MCC on this plant. We're walking through. We got all kind of drives, which we'll talk about. That speeds up a motor, slows down the motor. We're using the 4 to 20, right? And then we got regular full starters that opens and closes according to the 110, right? In the plant. We got big drives. These are big drives, right? These are little drives. These are smaller drives. Depending on what size motor, depending on what size starter, or what size drive. Same thing, big motor. You might have a smaller motor. Going through, you can see that this is a whole bank of variable speed drives. Like I said, for pumping. Like I said, instead of using a control valve to control the process, the variable speed drive will control the process, how fast or how slow we're pumping something. All right, and this is the MCC. So from the MCC, we're going to go over to the DCS. So this is the DCS room. Like I said, we got loads that come in. They go over to the modules. So it comes into here. If you look into here, let's go into the DCS first. We'll go in the back because I know it a little better. Right now, it's all labeled. Everything has labels, so I know which tank or which valve I'm working on and where it has to go. If you look, it tells you a number on it. That is for a reason. All right, and like I said, if you go on the one side of it, it tells you exactly what it's for. And if you go up, this is an input card. This is an output card. This is a input card, right? These are discretes, right? On and off. And then we go over to the next cabinet. Over here, and this will be on instruments. Again, I have instruments here. I have the analog in. That's what that card looks like. This is the analog out. And that's what that looks like. And these are all analog. Again, if you look at them, it says module 29. It's what module it's on. So if I have to look for that card, I can look at this number, go to that point, go over to here, and I know it's on module 29. I'll show you the detail of that when I get upstairs in the control room, the interface for this. So from here, I have a wire that goes from here, goes over to the nodes. And the nodes feed these modules, okay? Analog in, analog out, discrete, on and off, whatever, all right? Again, I'm only looking at a specific. Right now I'm looking at this right here, B. APM B. If I go over here, I go to APM B, that's where I'm at. I'll show you what I'm talking about in a minute. This is a cabinet that I was in. I wasn't in these. Again, if I was working on something on this side, it would be APM D, which would be this cabinet. But if you look right down here, this is APM B, which is the analog and where the module is for that one, if I wanted to work with it. And these are the nodes, and this is where the engineers program and stuff and send everything to this, okay? And then from here, it goes to the interface upstairs for, so they can do the controlling. So from here, I'm going upstairs. I'm still walking in the plant. This is a process, like I said, that's a big silo way up in the air. It goes up 6 stories. Right? Go over here. And this is a burner system which will heat the product up. You see it? Go down here. I got control valve for the air. There's a lot of instrumentation stuff on this. Like I said, this is another type of block valve right here. Up there, there's a control valve. Right controls the air. That's the air line over there. 1, 2, 3, 4 different terminals. And we got, if you look here, we have vector transmitters, pressure transmitters, I don't see any of them right now. I'm over here. Just gonna find them. There's an eye, there's a spider. Something we don't talk about in class, but I just wanted to show it to you. Alright. Now I'm walking up to the control room. I'm walking this whole time. Again, I'm walking here. Like I said, I'm on the 3rd level right now, heading up to the control room. Going down. Okay, now we're in the control room. Like I said, first thing you do when you come into a plant, you always go to the control room. From the control room, you always see the foreman. Right, foreman sits here. Operators are here. And then before you do any job, first always let the operators know what you're doing and what you're working on. And then the next thing is, like I said, hey, can you detail one for me, please? And this is the DCS. So this is the process for the whole plant that we're controlling. All right, and this is just one side of the plant, not both sides. And this is only one plant. We got a lot of plants here. So he's going to detail, and I'm going to show you so I can show you in class. He's detailing it right now. He's doing all this. He has the controllers right here. Where's that from?
We want me detail.
Okay. Do a valve, like a block valve or a control valve. So, can you pull up the point? You can't. So, this is how he details it. He can open and close it. Right now, you can see it says open, open, and it's saying open there, and it's in manual, and it's in program manual. All right, but there's other ways to detail it, but we'll talk about it later. Again, this is that burner that we walked down on. It has 4 zones. You can control it. Inputs, like I said, the burner, right, 480 motors, right, opening and closing the valves. We have these valves here, which are the air valves for each zone, degrees, analog input, right. We'll talk about it all in class. All right, I'll be talking to you, and I'll see you later. Thanks.